Good everyone, my name is Graphics. Today we'll be looking at another aspect of mechanical and science, which is what? Moment of forces, about a point. Now, the moment of force is the product of the force and the perpendicular distance from the point of the force to the line of action of the force. Now, when we talk about moment, we say moment M is equals to what? Force times perpendicular what? Perpendicular distance, right? And it is measured in what? Newton meter. That is the unit for moment. Now what means that? Let's take case 1. Case 1. If I have a force, let's say this force, acting at this object of length m meter, let's call it m, right? That is dm, distance m, in what? In meter. Then the force in Newton. Now, since this force is perpendicular to this line AB, our moment will be given as what? Our force in Newton multiplied by what? The perpendicular distance, which is what? D in what? Meter. Right? So, if the force now is to be 5 Newton, and the distance is to be what? 4 meters, right? So we'll say that the moment is equals to what? 5 times 4, which will now give me 20 Newton meter. That is it, right? Now, in case 2, case 2 here, if I have this same force, let's say we have a distance, the same distance, AB, right? And we have an inclined force. Let's call it the same force in Newton at an angle theta, right? And the distance from here to here is what? A meter. Is that okay? And we are told to calculate the moment. Now, to calculate the moment here, first of all, we have to resolve this force. So, to draw our free body diagram of this force, we'll be having something like this: vertical component and horizontal component, right? The vertical component will be the force cos the angle is along horizontal axis. If you watch my previous video, you get to understand what I'm saying here. And here will be the force sine the angle. So they are acting at this point here. From here, this is A and this is B. Then let's say from here to here is our distance D in meters, right? So if I calculate my moment, it's going to give me only the force times the perpendicular distance. So the force must be perpendicular to what? To the distance. So which force in between these two is perpendicular? It is the vertical force here. So I'm going to say my F sine theta multiplied by what? My D, right? So let's assume the force is given as what? 5 Newton, and the angle is given as 30 degrees. The distance is given as what? 4 meters. So my moment here will be the 5 sine 30 multiplied by what? 4. So the moment here will give me 5 sine 30 times 4. That will be 10. 10 Newton meter. That is for this case. So let's look at case 3. Case 3 now is when the beam is having more than one force acting on it. In this case, we are going to calculating for what? The summation of what? Of moment about any point. So I will take point A first. Equals to what? 0. Are we good? Taking point A equals to what? 0. So I'm going to put that. Consider that the upward force is what? The clockwise moment is positive and anti-clockwise moment is what? Negative. So let's see. If I take about point A, it means that everything in A will be equal to what? 0. A will be nothing other than what? A reference point. So all the rest of the forces will be coming towards this direction. All of them will coming towards direction here, right? So let's move. The first one is what? Is B. B will be going towards point A, as if it's bending, it's turning, right? And when you have your clock this way, this is 12, this is 6, this is 3, and this is 9, your work clock, right? Any that is going backward this direction is what? Is anti-clockwise. This guy is coming like this, and it's coming like this. So this is what? Clockwise, because it's going direction of the clock. So it's clockwise. So this is positive. So it will be 8, and the force is perpendicular to the distance. It will be 8 times 2. 8 times what? Times 2. Plus, this one too is coming towards the direction also, is also clockwise, positive. It will be 6 times the distance where I took moment from. So from here to here to be what you multiply the 6 with. Where I took moment from, that is what? Point A. It will be 6 times what? 5. Plus, the next one is this 9. The 9 is coming like this, right? And if you come to my clock, if you look at the direction, go in direction with the 9 too. And that is what? Anti-clockwise. It's going opposite the clock direction. So that we know what? Negative. So I'll be having minus 9 times the distance where I took moment to the point where the force is acting. And that is 2 plus 3, which is 5, plus 4, which is what? 9. So from here, 8 times 2 is 16, plus 6 times 5 is 30, minus what? 81. So 16 plus 30 is 46. 46 minus 81 is, we're having minus 35 Newton meter. That is my moment about point A. If I am very correct, if I calculate moment for every point, I should be having minus 35. But you're only allowed to calculate moment at one point. But for simplicity's sake and for better understanding, let's consider moment for every point. Now the next thing, let's go and check for what? Moment at point B equals to what? 0. I am consider my what? Clockwise moment to be positive and anti-clockwise moment to be what? Negative, right? So from here, let's see. Now, for better understanding, I want to redraw this figure here. Now, if you look at this figure, it's the same thing with the first figure. But to enhance your understanding, I will join them again, but I'm taking moment at what? At B this time. So if I'm taking moment at B, look at what will happen. It means everything in B, including the 8, is 0. B will be anything less than what? A reference point. So B is just a reference point. So all my force will be coming towards B. All my force will be coming towards B. So the first one is A. A will be going towards B. And that is what? This is my clock here, right? This is my clock. 12, 6, 3, and 9. And it's coming like this. And that is what? Clockwise. Abi? And clockwise is what? Positive. So it will be 5, this force. 5 multiplied by what? Distance from here to where I took moment, which is what? B. And that is 2. Plus, the next one is C. C is coming like this. And if you come here, C is going like this, right? And that is what? Still clockwise. So it will be 6 times distance of C to B where I took the moment. So 6 times from here to here is what? 3. Now put my 3. plus the next one is this one is coming like this, Abi, and which is here like this, is going like this, it's coming like this, Abi, and that is what? Negative, anti-clockwise. So it will be minus 9 times the distance of the point I took moment, which is what? B, to where the force is, and that is 4 plus 3 is 7. So from here, 5 times 2 is 10 plus 18 minus 9 times 7 is 63, right? So 10 plus 18 is 28, 28 minus 63 to give you minus what? 35. Now you can see we're having the same answer. Don't forget your unit, Newton meter. You said that I took at A and I also took at B. I'm still getting the same answer. Now the fun continues. Now let's take at point C and see if we get the same value also. Let's move forward. So I will draw, I'm taking moment at what? Point C equals to 0, where I want to consider my clockwise moment to be positive and my anti-clockwise moment to be what? Negative, right? So for simplicity's sake, I would like to redraw again. In this case scenario now, we're considering moment at C. So everything in point C here is 0. C is nothing less than what? A reference point. So C is just a reference point. All the force will be going towards C, right? So let's see. Let's start from A. Now, just like, let me use my clock. This is 12. This is 6. This is 3. And this is what? 9. Now, this force is coming this direction, going towards what? Towards C. So it will be, it's positive because it's clockwise, going like this. So it's positive, right? So it will be 5 multiplied by the distance of the force to where I take moment. And that is what? 2 plus 3. And that is 5. So 5 times 5. Plus, the next one is this. It's coming towards C, where I take moment from. And it's going like this. And that is what? Anti-clockwise. So it will be negative. Minus 8 times the distance of the B, of the force at B to where I'm taking moment from, and that is what? Here to here, which is 3, right? Plus the next one is, I will ignore 6 because that's where I take my moment. I'll go to the next one, which is what? 9 at point D. It's coming like this, Abi, and that is what? Negative. So I'll be having minus 9 times the distance of D to what? To C, and that is what? 4. So from here, 5 times 5 is 25, plus 8 times 3 is minus 24, plus 4 times 9, which is 36, plus minus 36. So from here, minus 36. So we have 25 minus 24 minus 36. So this will give us 25 minus 24 is 1. 1 minus 6, that is to give you minus 35 Newton meter. You can see all the answers are conforming. So irrespective of where you take your moment from, you also have the same answer, as long as what? The system is in equilibrium. As we solve further, I will make you understand what I mean by the system is equilibrium. What I mean, one of the conditions for a system to be in equilibrium is that what? All the upward force must be equal to what? All the downward force. So if you look at this now, the downward force here is what? Is 15, right? And the downward force here is what? Is 14. The upward force is 14. So as we move further, we'll get to understand more about moment. So if this video has benefited you, don't forget to share, like, and also most importantly, subscribe to the channel. God bless you. Bye.